In this video, we will be looking at significant figures. We're going to be defining what is a significant figure and how to apply it into our measurements. First, we need to understand whenever we are carrying out a measurement or observation, we're going to have one of two possible numbers to report. The first one is what we call an exact number. An exact number is something that is either a part of a definition or something you can count. Take for instance, the number of fingers that you have is an exact number because you don't have to measure them, you just count them. Definitions that come from prefixes, for instance, like meters to centimeters, and those are exact numbers. The second type of number that we'll see is what we call an inexact number. Inexact numbers come from actual measurements, and they contain uncertainty because of two reasons. The person that is carrying out the observation is not perfect, and neither is the instrument that that person uses. We need to make sure that we report that uncertainty whenever we're carrying out any type of measurement. In the case of the examples that we have here, for instance, we have the uncertainty. The first case is in the first decimal place at 0.3. In the second case is at 0.8. And in the last case is at 0.4 right there. All of them are more an educated guess than an actual measurement. They represent the place where you will find the uncertainty in your measurement. All the numbers that we report up to that one educated guess, we call them significant figures. All non-zero numbers will always be considered significant figures. They're part of our measurement. So for instance here, we will have three significant figures. 65.2, that last two that we have, is more an educated guess than an actual measurement. If you look at the second example here, our uncertainty begins in the number after the decimal place. That means that the second measurement is much more precise, therefore we'll have a higher number of significant figures. What happens when we have a zero in our measurement? Well, the zero can be either significant or non-significant. It depends on context. For that, we have a series of rules, relatively intuitive. We'll go over them real quick. The first one is that if your zero lies between two non-zero numbers, such as in these two cases, they are considered significant. They're part of your measurement. You can't just ignore them or just not write them. That would mess up your entire measurement. So they are considered significant figures. The same is true for a zero that appears to the right whenever you have a decimal place. Take for instance this first measurement, 3.7500. Those two zeros were not you don't have to have them there. So if you are placing those two extra zeros, there is a reason for it, usually to represent accuracy in a measurement. If you don't have a number after the decimal place, but you still want to count your zero as a sig fig, you just add a decimal place at the end. So 620, you add that dot right there, that makes that 20 as zero significant. Now, a zero can be non-significant or not count as a sig fig if there is no decimal place, like what we have here at the bottom, right? All those zeros, they're not significant, they're just there because they have to be. And the same is true when they're to the left and you have a decimal place, just like the ones that we have right here. They're placeholders, they don't really count towards part of your measurement. What happens when we have to deal with more than one number, more than one uncertainty? Well, it depends. Again, context is everything in this type of problems. When we are multiplying and dividing, we will report always the highest uncertainty we'll have. And in multiplication and division dictates the form of reporting the same number of sig figs as the number with the lowest number of significant figures. So in this case, we have 4 significant figures divided by something with 2 significant figures. So our final result must be reported with 2 significant figures. So I will need to round in order to report a final number. So I count 1, 2 sig figs, then I just cut right after that. I look at the number that follows. If it's 5 or higher, I will round up. If it's not, then I will not round. I will just keep the number. In this case, the number that follows is an 8, so that means that this translates to 64 miles per hour. Notice that we kept those 2 sig figs. which is what we have right here. The rules that I just mentioned apply every single time that you're rounding. Again, 5 and up, you round up. 4 or lower, you don't round, you just keep it. It really depends on the numbers that you are dealing with in that specific example. Lastly, when you have addition or subtraction type problems, you will go by the number of decimal places. The number with the lowest number of decimal places, that's the number of decimal places that you will be reporting. For instance, here we have 2 decimal places, we have 1 decimal place. So my final result must be reported with 1 decimal place. And that's pretty much the rules when applying significant figures to mathematical operations.